Okay, ladies and gentlemen, when we look at some of these application problems at the end of 3.3, the length of a rectangle, or actually a rectangular poster, is 1 foot more than the length of the width, and the diagonal is 5 feet. Find the length and width of the poster. Okay, I'm going to draw a picture of the poster. I'm going to call the width W. Now, it tells me the length is 1 foot more than the width, so algebraically that would be W plus 1. And the diagonal is 5 feet long. Remember that a diagonal connects corner to corner, so we know that's 5 feet long. Now, pay attention to the fact that this is a right triangle because this is a 90-degree angle since this is rectangular. So I basically have a right triangle here. One leg is length W, one leg is length W plus 1, and the hypotenuse is length 5. So if I apply the Pythagorean theorem, W squared plus W plus 1 squared equals 5 squared. In other words, the length of a leg squared plus the length of the other leg squared is equal to the length of the hypotenuse squared. So we have the Pythagorean theorem in use here. W squared is in the front. This part, I kind of go off to the side of the paper. And remember, do that with foil. But when you do, you're going to come up with W squared plus 2W plus 1. If you foil it out, you'll see that. And 5 squared is 25. Okay. Very important right here to remember that this really means W plus 1 times W plus 1, which of course would become W squared plus W plus W plus 1, which is W squared plus 2W plus 1. Remember, when you're foiling out a binomial, you're going to get a trinomial. That's a very important step. And now we collect like terms here. W squared plus W squared is 2W squared plus 2W plus 1 is equal to 25. I want to now put this in standard form, so I subtract 25 from both sides. 2W squared plus 2W minus 24 is 0. I can either factor a 2 out of here, or to be completely honest, what I like to do, since this is an equation, is just divide through. So I'm going to divide both sides by 2. Everything here, that's going to become W squared plus W minus 12, and 0 divided by 2 is 0. So when you have an equation, I prefer to just divide out the greatest factor that I can, because that leaves me with a much simpler equation to work with. And of course this factors. We have W plus 4, W minus 3. Remember, if this quadratic didn't factor, you have the quadratic formula to choose from. In some cases, completing the square might be a good option. It just depends on what the problem looks like. But remember, the quadratic formula is always going to work. This part of the problem, the answer would be negative 4. For this factor of the problem, the answer would be 3. You know, when I set them each equal to 0. What makes this 0? Negative 4. What makes this 0? 3. So those are my two answers for W. Okay? Now, here's the problem. W here is a width. Well, width can't be negative. So we immediately know that answer doesn't make sense. So the only answer that makes sense is the 3. So when I go back to my original picture, the width is 3 feet and the length is 4 feet. So width would be 3 feet and the length would be 3 plus 1, which is 4 feet, and those are our correct answers to this word problem. Okay, again, very important part right here. After we applied the Pythagorean theorem, length of the leg squared plus length of the leg squared equals hypotenuse squared. This part has to be done by foiling, i.e. distributing. A binomial squared becomes a trinomial. Because if you mess up here Everything else is wrong, so I don't want you messing up there. And we're done.